Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, I'm going to be revisiting this machine. This is the Apple Lisa 2/5 that I recently took apart on the main channel. This machine was graciously donated to the channel by AJ up in Seattle when I was up there recently for the Seattle ICF, or Interim Computer Festival. And when I brought this machine home and I took a look at it, I could see that, well, things were not looking so great inside. And that's because the battery that's in these Lisa 2/5s and the original Lisa have a tendency to leak and are very, very destructive. If you haven't seen that first video yet, I recommend you go watch that. I'll of course have a link to it in the description, and there'll be a little card or whatever. So with this machine, when I took it apart, as expected, there was a little bit of cosmetic damage on the metal structure of the case, and the outside was looking pretty good, but the main problems were with the boards that were inside the machine. This is the motherboard, and there's an I/O board that actually contains the battery, and that took a huge amount of damage along with the motherboard, which is where the card slots are. And then what we're left with is a CPU card that was kind of minimally damaged, and the RAM board has 512K of RAM, and both of these had just a little bit of damage on them. Now, in that first video, when I took this thing apart and I saw the extensive damage, I knew that there was really not going to be any chance of getting those original boards, at least the motherboard and the I/O board, working again. Not without extensive reworking, like removing everything from them, trying to recreate every single trace. It just really wasn't feasible, especially not for the time that I have. If I had unlimited time available and I didn't have videos to make, I could probably do it. Now, Lisa machines are pretty rare, so finding spare boards probably wasn't going to be something that would be likely to happen. But I had wondered in the first part if there were actually replica boards available, and yes, it turns out that there were. And I even put that on the end of the video, but a lot of people commented on there to let me know that yes, there were replica boards available. Well, it turns out that all those boards that are uploaded to GitHub and are open source and the Gerbers are available, you can get them made yourself, were created by Alex, who was someone I met at VCF Southwest in Dallas. Well, an unbelievable set of coincidences and circumstances. It turned out that Alex actually lives in the southeast of the US, and I had already had plans to go to the southeast of the US, including the city that Alex lives in. And those plans had already been made months ago, months before I got this Lisa. So I thought that that would be a perfect opportunity to meet up with Alex in person. And Alex offered for having me bring my CPU board and RAM board, the least damaged of the two boards that I have, for testing in one of his Lisas so we could see if those boards actually work. I couldn't not say yes, of course, because that would save me so much work. If I get all the replacement parts for this machine to kind of make it work again, and I put it all back together, and I turn it on and get a black screen, well, the problem could lie anywhere. And just knowing that the RAM and the CPU board work or don't work is going to be a huge step in trying to get this machine up and running. So what I'm going to do in today's video, as I am just about to leave for the airport, I want to take the CPU and the RAM board, which have some minor damage on them, clean them up as best as I can, get all the green crusty corrosion off of them to have the best chance possible of having them actually work in Alex's Lisa. So that's what we're going to do today, and without further ado, let's get right to it. So what I'd like to do here is prepare a couple of these cards so I can bring them to Alex for testing in his working Lisa. Obviously, there's no point to really do anything with this board. I think it's a little bit of a lost cause, isn't it? It's quite possible the PCB itself is theoretically savable. Oh, did I notice these bodges on the bottom before? I'm not sure I did. Clearly, these connectors have seen better days. One thing I did want to try here is I have this navel jelly rust dissolver. Now, what this is, well, to be honest, I'm not sure what this is. Yes, there we go. Contains phosphoric acid. Avoid contact with skin and eyes. Yeah, I definitely try not to get this on my skin, but it's this pink liquid. And I found it does an amazing job at eating away this corrosion here. So I'm just going to put a little bit of it on there. And I think this is actually already foaming up. The corrosion from the battery comes from a very strong base that comes or leaks out of those NiCad style batteries. And the green crusties are actually the copper itself getting eaten away. So normally these are plated, usually gold plated, and there's copper underneath. Well, I think that the strong base of the battery leakage gets to the copper and starts to corrode it. And that's why you have all this green crusty stuff coming out. I'm not sure I noticed this last time either, that this connector's actually broken. So the nice thing about this versus, say, vinegar, which is also an acid, is a much milder acid than this phosphoric acid. The nice thing about this is it doesn't go away. So you can put it in a position like on the contacts for the card here, or the card edge contacts, and then it will just sort of do its thing. Now, of course, what you have to remember when you're applying this stuff is, well, don't touch it, first of all, and then also, you really need to wash off what you're applying it to. And to be honest, I need to prepare these cards to bring to Alex for testing, and I'm not going to bring this one. I just wanted to show a little bit of an experiment here. I think this is kind of how I'm going to be treating this stuff. Oh yeah, look at that, look at that. So I'm not going to be bringing this card with me. What I need to do is, because I don't want to leave this card just sort of corrode away, is I'm going to go wash this off. I'm going to let it sit though a little while, and we'll be able to compare what this treated part of the connector looks like versus the untreated part there. Either way, I'm just going to let that sit for a little while we look at the other boards. So what I need to do is I just wanted to clean up these boards a little bit, the ones that I'm going to be bringing to Alex for testing, which would be the RAM board and the CPU board. And we have a little bit of corrosion on the connector plus some corrosion on these traces here, which may or may not be a problem. And I think what I'm going to do is I'm going to use the Dremel, and I'm going to try to polish this up a little bit so I can see if the corrosion that's under the solder resist is actually going to be a problem. Obviously on the ground plane there, not a big deal, but we might have some broken traces. So we have the RAM board to look at. This is the IO board that's incredibly corroded, so I'm not even going to bother with this one. There's no way this board's going to work right now. And then we have the CPU board, also needs a little bit of cleaning up. This one's in much better shape than the RAM board. I don't really see any bubbling or corrosion on the traces along the bottom edge. I just have to try to sort this out. And on the back side, we obviously have some of this green crusty corrosion on here that I really need to kind of deal with. I don't want to stick this into Alex's slot on his actual working Lisa. All right, first things first, I'm going to use some of this navel jelly just on the edge here to get rid of this green crusty stuff. And I will need to wash the board off just to make sure I get all this navel jelly off before I do any further treatment. What I'm hoping this is going to do is anywhere there's a little bit of the corrosion that's coming through the plating, like right there, it's actually going to expose it as fresh copper. Because the intent is I'm going to tin that part of the connector, the damaged part, and that should allow it to make contact in the slot in the actual back plane of a working Lisa. Okay, let's do the same thing on the top side of the PCB. On the top side, even though we have these little black spots, see how they're actually turning a little bit more coppery looking? I think that's just some oxidation that's on the top layer from the corrosion that hopefully this navel jelly will eat away at a little bit. While we wait, take a look at the connector there. Notice that's looking remarkably better. This stuff is great. It really is good. Now, one of the unfortunate results of using the navel jelly on these connectors is that it will remove the plating. If the corrosion's only on the very top edge, and you can kind of see it's still a little bit gold looking down there, maybe all I need to do is when the copper gets exposed, I could just paint that with some lacquer, because it's actually the fingers down below that make contact with the card when you stick it in the slot. That can work, but I'm not sure in the case of this connector, it's actually going to work. Remember that when this was untreated, it looked like this. So that's already looking quite a bit better, quite a bit better. Now I am curious about these traces down here. Look how that foamed up immediately. I think to fix this IO board, if it were even possible, I'd have to desolder all of these connectors, then sand down the entire board to expose all the copper, fix any of the broken traces that might exist, like over here, there's certainly going to be some, then put some lacquer on top of this somehow, and then reattach these connectors. Part of the problem is, of course, that once you put lacquer on top, it then becomes really hard to solder. And that's why when they apply the solder mask at the factory, you know, they have a template or a mask that they applied first, so they don't put solder mask on top of things like vias and stuff like that. Let me just go wash off all the navel jelly that's on here so we can take a look at how that looks with the navel jelly removed. Obviously, this could use some more treatment, but it made a big dent, and it's kind of interesting to see how effective this stuff really is. And there is our washed board. It doesn't look nearly as bad now that it's been washed. And you can see after washing, some of the green crusties came off this connector. That's the navel jelly was on this side, but it does look better. I mean, it's theoretically possible that with enough soaking in navel jelly, maybe that connector could possibly work somehow. Definitely of these 3 unobtainable connectors, this one is the one that's a little bit corroded, but maybe that'll clean up okay with navel jelly. These 2 actually look fine. When it comes to the connectors that are on this board, well, pretty much all the parts on this board, everything is pretty much obtainable except for these 3. I think these are unobtainable, but these 2 look fine actually, and this is the one that needs a little bit of work with probably some navel jelly. Either way, I've definitely gotten off topic here trying to work on this thing, so yeah. I need to get back to the task at hand, which is trying to deal with this stuff. Interesting that it's sort of foaming up there a little bit. I assume that's what's happening. Let's take some of this water here and just wipe this down. Okay, good. This is kind of what I was hoping would happen. It looks like it is actually turned the exposed copper shiny again. So I'm gonna take this upstairs and give it a good wash just on the edge connector and just make sure that I wash off all of the navel jelly. All right, there we go. So we have exposed copper over here, but I don't really get what's going on this side. Why is there still this green and crusty even after a lot of scrubbing with soap and water? That's strange to me. Let's check the backside. Oh, the backside looks the same. So a little bit of exposed copper there. And then all this green stuff just on the middle part. It's almost like it's impregnated into the fiberglass material that makes up the PCB. The other thing I think to do is use some 99% IPA and just really scrub this. That did absolutely nothing. Nothing at all. All right, my next tactic is going to be some magic eraser. Maybe I have to use a little bit of abrasion on this. And I'll use deoxit as the lubricant. Okay, well, it's kind of hard to tell in the camera, but it's kind of green looking on the magic eraser. It certainly looks better, but still a bit on there. I'm going to do another pass. Okay, a little bit more green came off on there. I mean, I still see green on here though, but it's certainly a lot better. All right, let's try this top side here. Well, we definitely have an improvement. There's still green there, but it looks way better than it did before I scrubbed it with magic eraser. And on the back side, yeah, it's still some there as well, but it looks a lot better. One thing that looks good is I don't see any broken traces. All these fingers look like they are attached properly. And even though we had little holes where the corrosion was, I think even for now with the deoxit on there, which is a little bit of an oil coating, it'll keep it from corroding again. And then in the future, the ones that are quite gold color, I can tin those with solder, and that should keep them from corroding in the future. Solder does not have as good conductivity as this gold plating, so it's not ideal because it oxidizes and it's just not as good, but it's certainly better than copper. Exposed copper is definitely going to oxidize, and that will not be good. Every time I scrub this, more crap comes off, which is good. So I'm just going to take one more pass on the top side. I'm a little bit concerned with what's happening right on this finger. See how it's green and still on the left side? Feels like the corrosion is just underneath the finger or something like that. And no amount of polishing seems to do anything. All right, I think that's gonna have to do for now. Everything looks like it should be good for testing purposes. And even though that looks a little funky there, I think that should be fine. The fingers should make good enough contact. And same thing on the backside, is looking a whole lot better than it was. Okay, cool, that's the CPU board down. Let's go to that RAM board. So first things first, let's do the same process with the magic eraser on the edge connector. Yeah, things are looking pretty rough here though, aren't they? Pretty rough. Oh, look at all this. I think I'm gonna start with a little bit of IPA just to get this all clean at least. You can see wiping it, you get a little bit of the green, a little bit of the oxidation. So I think what I'm going to do is I'm going to use this Dremel with this polishing bit. I'm just going to give a little test over here on these traces. It's going to rub away the silkscreen markings. I'm not too concerned about that. I just want to see what things look like underneath this corrosion here. Right, so that was a good little experiment there. And it looks like everything is okay, actually. It's nothing broken under there. It's just corroding underneath the solder resist. This definitely makes a bit of a mess, but this isn't just corrosion coming off, that's the actual solder resist. This looks odd right there, doesn't it? Now, I don't think that's actually broken traces. I think that's just the way the corrosion looks. There's like some gunk in there. And look at that, with more sanding, we could see that those aren't actually broken traces. It was just some of that gunk on there, the corrosion that's on top of the copper that just makes it hard to see in the camera. But looks like nice shiny copper there, doesn't it? Now, luckily, all of these potentially broken traces are along the bottom edge. I don't see anything in the upper areas. That means that if I have to sand this all down later, it shouldn't be too difficult. And for this stuff that I just exposed, it's not a big deal. I can just paint over this with nail polish, which is a clear lacquer. And if I need to remove it in the future to, say, fix a bad trace or whatever, I could just use some acetone. I will take that right off. Now, the one area I do want to focus on is the connection from the fingers to these vias, because that looks bad. Like, for instance, is that supposed to be connected? Because it's certainly not connected. That's obviously not connected because it looks just like that one. It's sort of a nice rounded end. And those are all connections. That one's not connected. And let's do these. All right, I'm pretty confident that everything on the top side is fully connected, and it doesn't look like any of the traces were broken in this whole area, which pretty much tells me that probably it's fine over here. So I'm not even going to bother sanding this stuff unless I need to at some point in the future, because if this board's not working and we find that there are large busted parts. So now to the back side, yeah, it's looking kind of bad. I'm just going to do the same exact thing again. Right on the back side, I think everything is connected here as well. I just don't like how actively green this looks. I'm going to sand this off. Now, looking at these traces that lead up to the rest of the board, looks like there could possibly be a break right there. I'm just going to use this little engraving tool. Oh, that looks totally fine. No issues whatsoever. Cool thing about the engraving tool is you can be very targeted with where you grind down the resist. It just allows you to get a better view to see if you actually have a broken trace somewhere. That one looks pretty thin, but I think it's fine. All right, well, this RAM board's looking a little worse for wear, but I'm much more confident that things are looking good on the connector and with all the traces. This should work. I'm pretty confident this should work. So I'm gonna go upstairs and give this a quick wash just to kind of get off all the dust and crap that's on here. And then what I'll probably do is I'll just paint some nail polish over the exposed copper parts, and I'll just make sure to leave this part free, and it should be good for testing. All right, I'm just checking. Everything looks pretty good. Don't see any green crusties on there. The CPU board, that is. Backside looks fine as well. It's just a little bit of corrosion there on the edge, but don't think that's going to be particularly a problem. That finger doesn't look super great, but I'm pretty sure it's got connectivity all the way through. Yeah, it does, even from this crusty looking via. So even though it looks like it's got a break there, it doesn't really. Okay, in the RAM board, I've done the cleaning. And now I'm just gonna apply this nail polish onto the copper. Now remember, it's easy to remove with acetone, which is something that's widely available, at least in the place I live here in Oregon. So I have to make sure what I don't do is paint it on the fingers. If I do, I'll just have to clean it off. Not that big of a deal. Now I know some people like to use that UV curing paint. I do have some of that, but I actually prefer the nail polish because it allows me to see right through it. I can see down to the traces that are underneath there. So if anything is going wrong, like any corrosion in the future, I will see it. It's not going to be hidden behind some dark green paint or whatever. Now, if this board works, I think at some point in the future, I'll probably remove the nail polish and I will work on getting rid of all the extra corrosion that's on here. See, it's a little bit green and crusty there, for instance. I'll spend some more time on it, but I'm a bit pressed for time right now because I need to get this ready for my flight. So that's why the work I'm doing here is a bit rushed and slapdash, so to speak. So while I wait, I'm just going to try to clean this area up over here a little bit. Okay, that looks a little bit better over here. I mean, I know that was just a tiny bit of the green crusties, but I don't like it, and it looks better now. There's something really weird going on with this trace right here. Just sort of scratching at it. I don't know, it seems like it's lifted from the board almost. And what about right here? It looks a bit weird. Okay, yeah. I think there was just some corrosion underneath the trace there. I'm using this engraver without the motor even spinning. The solder resist is so weak on this from the corrosion that it's just flaking off. I'm just going to put a little nail polish on that while I'm at it. I think this board is going to work. Worst case, we have a bad trace somewhere around here. Worst case, I just clean off the nail polish, use something like this to expose that trace, and then we just add a bodge wire. This stuff is really nothing to worry about. These large power planes, ground planes, I think based on the fact that I've exposed a whole bunch of copper and I haven't found a single bad trace anywhere on either of these boards, I have a feeling none of these traces are in bad shape whatsoever. Now that brings me back to this motherboard. I am curious about like these, because these traces are literally bumpy. But I think that's a break right there. And that's a break right there. Yeah, 100%, that's a broken trace. And so is that one. So just in this area alone, we have 2 bad traces. And I have a feeling there will be many more under here. Like it's all bumpy because of the corrosion that's under the mask. Oh, and over here as well. Same thing. Yeah, this whole board is, whoops, I literally just broke that. It's really hard to tell, unfortunately, when you have this dark solder mask and the corrosion's underneath it, where these bad traces are. And I know you might think that's just copper under there. It's not. I'm just eating right into the fiberglass itself. It's sort of a brown color. There's another broken trace I just exposed. And there's another broken one right there as well. And that one's bad as well. There was a little bit of copper there, but just me touching it with the tip just broke it away. So because it was so thin, there's really nothing there. So this is going to be the common thread on this board. It's going to be filled with incredibly thin traces just like that, or completely missing ones like that. And I don't know enough about material science to say whether things that are connected but say really thin like this will over time corrode and become a broken trace. Look at that carnage right there. That's a big chunk of a missing trace. Oh, and that one's coming off as well. Oh, it's getting worse. It's getting worse. Okay, well anyways, I knew this was going to be a lost cause. This particular motherboard, or the backplane as we want to call it, is just going to be completely wrecked. And this was because the battery leaked directly onto it. But this RAM board, on the other hand, I have high hopes for. I think this board hopefully should work. I mean, it might have a bad RAM chip or two on it, but maybe when it's plugged into a Lisa, there's some actual RAM diagnostics that can identify which chips are bad, especially if this is a second RAM board, because I think the Lisa can take 2 of them, and this is 512K. And this is the CPU board, which I've already bagged up. I think this one's going to be fine as well. There's certainly no corroded traces on here, or at least none that are obvious. And then the fingers on the connector are looking a little worse for wear. But I know from experience that when they look like this, all I have to do is tin them, and that covers up the exposed copper and should allow it to work for pretty much indefinite time in the future. Even if the solder is not as good from a contact perspective as the gold, it's still good enough if we're not putting it in and taking it out of the slot all the time. Okay, so I'll just pop the RAM board into here, and with that, the boards are ready to go in my suitcase, and then next stop, Alex's Lisa for testing. So I hit the road to go see Alex, and what follows is some chaotic footage because I'm really not good at recording on my phone on the spot, so I apologize for all the shaky camera and jumping around, but I'll summarize at the end just to kind of talk about exactly what we did. The first thing we did is test my RAM board with Alex's setup, just to validate that it was working, and believe it or not, it was. So now we're going to test the CPU board.
Yeah.
This is the big moment, the more complex card.
This one's stuck a little bit.
Wonder if it's like bent or something.
Yeah, that happens sometimes. I get a little bit. All right, I'm gonna take the RAM
No worries.
out.
So you could see the,
see the
card slot.
Connector. Yes, it is bent a little bit.
I think the whole, yeah, cool. Boom.
Ooh, that was a funny noise. You hear how
it was crunchy sounding, but
yeah.
I cleaned the hell out of that connector, so it wasn't.
That's funny. I've never heard that before.
Power it up.
3, 2, 1, go.
Oh no, it's dead. Oh no, it's dead as a doornail.
we can try a few things before we.
Oh, and it beeped though. We had a single beep.
We did.
Why don't we try power cycle it maybe, or you turn it off and maybe we jiggle the card up and down.
Yeah, that's what I'm thinking.
Or a little bit.
That's what I'm thinking.
Because we could have a bad finger on there. Who knows?
Absolutely. Or just bad connection. I mean, it sounded really crusty. We'll see. I'm just gonna pull it out and shove it in a few times.
Yeah.
See if it sounds less crusty now. That still sounds a little weird. Go.
No. Okay, so it's good. It would have been up by now.
Oh yeah, it would have been up. Let me try hitting the power button. That's what.
Oh my God! It's doing more than it was doing. Look, it's.
Oh, okay. Something's off. It is. It's doing something.
It is a sign of life. Look, CPU has a tick mark.
57.
Same. So
That's fine.
the way it's reading out the video is unless this is an RGB to HDMI timing thing. Because you know, like if the timing is slightly off.
Yeah. It's just weird that it was working on my board.
Right, but I wonder if the crystal is slightly different or something, so the video frequency is slightly. So I just fiddled with the RGB to HDMI, and there we go. So maybe we should do a reboot again.
Yeah, let's do it.
Yeah, power cycle it. I cannot believe so. Taking it in and out of the motherboard there a bunch of times, it just suddenly magically works.
I still don't know why it was so slow
Why?
to boot.
What's it doing now?
Oh, I turned it off.
Oh, try turning it back on. Okay.
All right, ready?
Yeah,
3,
go
2,
ahead.
1, go.
This is like longer than yours takes.
Yeah, something's weird here. And then it. I wonder if the reset. Something's up with the reset circuit.
Interesting. Quite possible then. Okay. This is the RAM board and the IO board from the messed up Lisa, and there it is.
Yeah,
Pixel perfect.
that looks great.
This is the IO board that Alex's. It's already having an error. So okay.
I'm gonna hit the
Wow.
reset button. I'm gonna hit the reset button.
Okay.
And let's see if it takes forever again.
Okay. It doesn't even work. So the reset circuit's messed up.
Wow.
If we plug a mouse in,
Yeah.
Oh no, it
took
did reset.
forever. Something is wrong with the reset
Okay.
circuit.
So it's like the capacitor.
The capacitor's
I don't know if it's
messed
an RC circuit. I never looked at it,
up.
but
555 timer.
oh, it is. Okay.
RC, yeah, basically.
Okay. Yeah. So, okay. We'll look at that, and then obviously we have a slight timing difference between your board, which is the video generation circuitry, that causes RGB HMI just slightly different.
That's nothing to worry
Yeah,
about.
that's nothing.
just-
I mean, on a CRT, it won't even matter.
Nah.
Wow.
Well, that's an excellent sign.
I can't believe it. Will it boot with that S57? I guess it won't, because the floppy controller is the problem, right?
We can hook up a profile.
Oh, because it says startup from, like, as if
Yeah, we
it
can
can.
hook up a profile and boot.
Okay.
Fine.
Okay, we have a different IO board, and let's see if this one passes. Is it still the bad?
Imagine this IO board fails too. That would be so weird.
I know that.
What?
Whoa! So it's like your back plane is the only thing that makes sense,
Oh, that's weird.
or is it? Well, you know better than me. Does it have to have a drive connected or whatever for it to pass this
No, it
test?
shouldn't need to have a drive connected. That's
So second IO board and both CPU cards and both RAM boards result in 57.
third IO board.
This is impossible. Okay, so we have a keyboard thing, floppy emulator hooked up, and it's gonna do boot.
Yep. Okay.
Here we go.
All right.
Okay, so it had trouble booting that disk.
Yeah. Of course, we're having all the Lisa problems while you're here. Sorry about that.
Well, you're
This
the
is
one.
how it goes.
You have like multiple things. If we didn't have multiple things, okay, we still have activity, so that's good.
Yeah, it's booting. It's trying to boot. We can see it's seeking, so it's trying.
That's not a mouse pointer. That's just like a
No, that's
dialogue box.
Wait, hourglass.
Uh-oh.
Oh no.
Oh no.
Oh no. That could mean either corrupted disk or problems with your boards.
We booted the other known good cards off of the profile emulator, and here we go. We're gonna boot this one now off the profile. Let's see.
This is gonna take a while.
It's not actually booting, is it?
It is.
Oh, it is booting off the profile. Okay.
Yeah, you can see some disk activity there. It's just gonna take a
All right,
second.
512K. Yeah.
Oh, we got a mouse, we got a cursor.
So that's
our
good.
first
It's
good
coming
sign.
alive.
And then the corner's round. That's our next good sign. Then we should get the welcome to LOS pop up. There it is.
Whoa. It's actually, what's 7/7 mean?
There's 7 applications.
Okay.
You know, Lisa Write, Lisa Draw, Lisa Graph, Lisa Project, Lisa Calc, Lisa Terminal, Lisa Graph, and Lisa List.
Okay. Wow. So we are, so this system, obviously we're not running, but it's running a lot more than I would have ever suspected.
Yeah. Well, it's not Celebrate yet. We're not quite in
I
all
know.
the way yet.
Yeah.
But like it's almost there.
I mean, look at that. It's coming to life.
We're in.
You have to open the cat picture.
Yeah, we got to open
Yeah.
the cat. I'm bad at drawing, but it looks okay. It looks okay.
Once this is booted. Amazing. Just so the reset circuit is our fault. Oh, shocking. A clock calendar. Yeah, the battery destroyed everything.
Big surprise there.
Using a 512K Lisa is an exercise in patience.
It is indeed. Works okay in MacWorks, but in the Office system, did it even register? I don't know if it did.
The hard drive light is still going crazy, so
Yeah.
it's, oh, there it comes.
our cat.
Just a moment, please.
Oh no! Oh no! Oh no! Oh no! Because it's your CPU board, not mine.
So it's paired to it or something?
Yeah, there's a serial number in this chip. There's a serial number in this chip. It has DRM that keeps it from
1983 DRM.
Oh, that was so much. I actually have a patch version of the Office system that'll
Does work on anything?
Yeah.
Okay, well,
But
long story short, we clearly are up and running with the RAM and the CPU board, and it works.
it works.
We couldn't actually get it working, but okay, well, there we go. That's freaking awesome, because it does freaking work.
It does.
Well, there you have it. I'm back home, and frankly, I can't believe that both of these are working. So just to recap what you saw in my bad cell phone video, I got to Alex's place, and first we tested out his board set, so the stuff that he had, just to make sure that his display setup and power supply and everything was working. So that's his I/O board, his CPU card, and his RAM board. It was all working except for that floppy controller error, which I showed in the footage. Then we put in my RAM board, and it just worked. It worked exactly the same way as it did with his RAM board. And then we put in my CPU board, and that's what you saw in the footage. It started out with a little bit of glitching, and we just reseated the card a few times, and then, well, it just started working other than the RGB to HDMI weirdness. So I'm frankly elated that the CPU and the RAM board are working great, even with the corrosion on the fingers of the CPU board and those potentially bad traces. Obviously, we don't have any issues. The only small issue we have is with the CPU board, which handles the reset circuit on the Lisa, and it's really slow to turn on. It should start booting in just like a second or so, but it seems to take like 3 or 4 seconds before it actually starts to boot, and the same with when you hit the reset button. So obviously that's a little bit of a fault that I'll need to address, but obviously it's not a major issue. It just takes a little bit longer than expected, which initially when we were doing the testing, we were like, oh, the thing is broken. But the reality is you just wait a second and then it started working. So I really can't thank Alex enough for taking time out of his day to help me test these two boards just so we could rule out absolutely for sure there's nothing really wrong with these two, and that once I get the I/O board and the motherboard situated on the computer, along with the power supply, of course, then I should be up and running with a working Lisa. Well, barring the CRT thing not working as well, not to mention I don't have the keyboard and I don't have the mouse at the moment. Now, a working CPU board and RAM board is a step towards getting a working Lisa, but clearly we need more. And Alex came through again, not just by testing these boards, but Alex also had some spare PCBs that he was able to give me, including this, which is the I/O board. This is the one that's massively damaged because, of course, the battery went right here and caused massive damage all over the board. And then we have the blank PCB for the motherboard, or the backplane for the Lisa, which of course has those weird funky card slots that kind of open and close, not to mention these large connectors for the CPU, I/O board, and RAM. These two boards will make it possible for me to reconstruct the missing parts of this Lisa to hopefully get it working. Now, Alex created these boards but released them as open source, so the Gerbers are available for you to download and make yourself. One of the issues, though, is of course in the US where I live, the tariff situation makes getting PCBs kind of difficult, not to mention if I wanted to order any that were this nice ENG or gold coating, that costs extra, and you have to have, what, the minimum order of 5 if you're gonna have these made up. So getting these made would be pretty expensive. So it was pretty amazing that Alex had these two spares so that I could, well, start my journey at reconstructing this Lisa. In addition, if you recall from part 1, when I took the machine apart, besides all the damage that was inside from the leaky battery, for some reason, the computer was missing its power supply. And again, Alex came through, and if I reach down here, here's a replacement Lisa power supply. And even better, this happens to be one that's for 220 to 240 volt machines, which we know the Lisa I have came from Germany originally. So this is the appropriate power supply for this computer. Luckily, these are very easy to modify 420 volts. They're very similar to the Acorn Archimedes power supply, where I think there's a jumper link inside. Alex thinks that he might have modified this for 120 volt operation, although we'll have to open this up just to validate that all the caps are looking good and that that modification was done before we actually try this thing out. But look at that, I basically have, well, almost all the parts necessary to make a working Lisa. We have the power supply, the two PCBs that were badly damaged, and then the two working boards, RAM and CPU, to have a working freaking Lisa. There's one more blank PCB that Alex gave me, and it's this one, which happens to be a SCSI controller for the Lisa. So there's the internal 50-pin ribbon cable connection and the 25-pin DB25 SCSI controller, EEPROM, and then some logic ICs, even has a Molex power connector. This goes into the Lisa motherboard in one of the card slots there, and gives your Lisa the ability to use SCSI devices. Now, I don't know too much about SCSI on the Lisa. I mean, I really don't know anything about the Lisa at all. In fact, just seeing Alex in person and testing out these two boards at his place really educated me a lot about how the Lisa works, how the boot process works, which will actually be very helpful for me when I actually get to the point of powering up this machine. So I have no idea if you can actually boot SCSI devices on the Lisa, or you have to use a floppy disk, or you have to use a profile, and then it can then go to SCSI for just additional mass storage. In the footage where we were testing the CPU and RAM board at Alex's place, you saw that we were booting the system, or the OS, using a profile hard drive emulator. The profile is actually Apple's hard drive that was designed for the Apple III, but also worked on the Apple Lisa. Believe it or not, I actually have an original profile hard drive that someone gave me probably about a year or two ago that I was intending to try out and use with my Apple III, but I never actually tested it out. I know it spins up. In other words, the hard drive seems to be working. It passes its diagnostics, so I assume it's working properly. But because I haven't really gotten my Apple III out to test it out lately, I haven't even tested that drive. So theoretically, that drive could work on this Lisa once this Lisa is up and running. Luckily though, I actually have one of the hard drive emulators, the profile hard drive emulators, like you saw in the footage at Alex's place. This particular assembled unit was given to me by local viewer and friend of the channel, Super SVGA, who actually did a lot of work helping figure out a lot of stuff on the Plexus, among lots of other people. But that means that when I get this Lisa up and running, I at least have this emulator to then try to boot the system, and it's going to work a whole lot better and more reliably than the original profile hard drive, which I think is just 5 megabytes in size. And you can have emulated drives on an SD card that are quite a bit larger. I have to admit, when it comes to this Lisa, when I first took it apart, I was really daunted by how bad the condition was of it. Really shocking, to be honest, considering how nice the outside of the case looks, cosmetically that is. And with a system like the Lisa, where you have a card cage holding different components, different constituent components, if you're at a situation where you have a black screen, it's really, really difficult to do troubleshooting, because unless you have spare parts, like other boards you could swap in to at least identify which of the boards is causing the issue, troubleshooting a board, even if you know which one is wrong in a working system, is just difficult because it's installed in a card cage and some of the cards are just completely inaccessible, at least for the chips. You can't even probe on them while the system is running. I'm assuming back in the day, whoever was actually fixing these boards for Apple must have had special test jigs that would raise the cards out of the card cage slot. Like you take apart the computer and then you would run it outside of the machine, a special jig that allow you to probe the board and try to figure out what's wrong. But without actually having those things, like me here, I don't even have spare boards. I don't have any way to test this stuff out of the system. It's really just daunting. So the fact that I can rule out the RAM and the CPU board and know that these are working is just a huge relief. And now it's just a matter of trying to gather up all the parts to actually make these two PCBs, which I don't think should be too difficult. And in fact, I know on the I/O board that I have, there are definitely components on there that are fine. The battery leakage is sort of like this section of the board. That means that this section up here is good, and I could probably just take all those parts off, transfer them onto this board, and then just install a bunch of sockets on here, the crystal oscillator, and then I have to order a bunch of resistors and passives and things like that to get this thing completed. So all the stuff that I've shown so far in this video has actually given me some hope that I'm closer than I thought at getting this Lisa working. But something else came up after I posted the video on the Lisa. Someone I know that I met at VCF, Jared, down in the Bay Area, hit me up after that original Lisa video went up and let me know that he actually has a spare Lisa that's sort of a parts machine. Basically, it was a barn find that he bought a while back to try to fix up his Lisa. So he has two Lisas. One's a barn find, one is not. One is in better condition, but it had some damage, some physical damage done to it. So he bought the barn find Lisa to try to combine all the parts to make one working Lisa. Well, here's where things get really interesting. Jared told me that once he combines his two Lisas together to make one working Lisa, all the extra parts that he had from the parts machine, he'd be willing to just send me. Oh, I said, of course, because we know that there's a bunch of damaged connectors and cable harnesses and things in this machine that are just super corroded. And what's really lucky is that his Lisa and the parts machine Lisa were both Lisa 2/10s. Well, a 2/10 is a little different. It has an internal 10 megabyte hard drive, so it's not directly compatible with this 5 or 2/5, but the 210s don't have a battery installed on them. So they don't ever have battery leakage. That means on the motherboard that he's going to send me, while it's not drop-in compatible with the one on this, especially because it lacks the parallel port for the profile hard drive, as that's routed internally, things like the connectors that are damaged on my motherboard are totally compatible with this board. So these 3 expansion slots, these 4 connectors, and potentially some of the passives that are on here can be salvaged off the other motherboard from that 210 machine and transferred onto this new PCB. And that just means I won't have to try to procure those parts, which I'm sure all this stuff is possible fine except for these strange connectors for the slots, because they're the weird opening ones. But if I can just salvage them off his motherboard and stick them on here, then that just makes everything that much easier. And I'm sure that the main I/O board is also similar-ish. There's definitely a big difference in the way the floppy controller section works, because this Lisa, the 2.5, is compatible with Twiggy disk drives, but the 210 is not. They basically changed the floppy controller to only work with Macintosh-style 3.5-inch floppy drives, while this one can work with either. Well, it really works with Twiggies, and there's a small adapter board that's over in the chassis by the floppy drive that converts the Twiggy signals to the regular 400K floppy drive signals. So as of making this video, the box of Lisa 210 parts is already on its way to me, so I should have that hopefully next week or so. And that means really with all these parts I got from Alex and the stuff I get from Jared, I should be that much closer to having a working Lisa. So I think that's going to be it for this video. I know it's a bit of a shorter one because really it was just about me testing those Lisa boards. And huge thanks to Alex again for supplying me with all this stuff and taking the time to test my boards for me. Absolutely awesome experience. And Alex is such a nice person. Really awesome to meet him, and it was very fortuitous about my travel plans. It just happened to coincide with me getting this Lisa and then Alex having time to be able to meet with me to test this stuff out. It was just like serendipity that it all absolutely worked out. So I hope everyone's been enjoying this series so far. I know we're early on. There's going to be a bunch more, but if you did, thumbs up. If you didn't, you know exactly what to do. Huge thanks to everyone who's helped me out so far. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.